Hello, my name is Kristen Bowman, and today we'll be talking about the effects of semantic priming on abstract versus concrete words. Excuse me. So, in the original study, Meyer and Scanvendelt presented participants with two strings of letters, aka words, and in half of the cases, one of the words was spelled incorrectly, and in the other half, both words were spelled correctly. So if both words were spelled correctly, participants were instructed to indicate yes, that both words are correctly spelled English words. However, for the other half of the trials where one word was spelled incorrectly, participants were instructed to indicate no, that they were not both correctly spelled English words. So why is this important? Basically, whenever we want to investigate the relationship between two words, we kind of have to mask what the task is. So Myers-Scanvendelt only focused on the correctly spelled English words. And in my study, I looked at both the correctly spelled words and the incorrectly spelled words. Additionally, I wanted to take my research a step further and look at the abstract versus concrete words, because I noticed that some of the words were probably processed faster than others. For example, house can be mentally represented. We know what a house looks like. However, how do you mentally represent love and trust? So my hypothesis is that participants would be faster to process concrete words versus abstract words, and if they were semantically related, they would be processed faster than unsemantically related. So semantically related words are like doctor and nurse. So they are in the same category, excuse me, they are both health professions. However, they are more related than doctor and butter. Like a doctor could eat butter, but those aren't in the same category. One is a food and one is a health profession. So I ended up with 4 different types of word pairs. Actually 8 if you include the filler words versus the target pairs. So first we have semantically related versus unsemantically related, abstract versus concrete, which we already talked about, and then target pairs versus filler pairs. So the target pairs are both words are spelled correctly, and the filler pairs are one word is spelled incorrectly. So participants were given a blank screen for 500 milliseconds, and then they would have a fixation point for 500 milliseconds, and then they were tasked with a decision. So my example here is doctor and nurse. So doctor and nurse are both spelled correctly, and they are semantically related, so participants would say, yes, they are spelled correctly, and what we know as the researcher is that if they are semantically related, they will possibly be processed faster, so a faster reaction time, than if they were unsemantically related, such as doctor and butter, and this is in our concrete section. So in our abstract section, loving and caring are both spelled correctly, and they would be processed faster, versus loving and success. Those really aren't in the same category. As for our incorrectly spelled words, we have doctor versus nursey, so N-U-R-S-I, that is obviously spelled incorrectly, and doctor versus butter, doctor versus B-U-T-T-I-R, but tier, that is spelled incorrectly as well. So let's look at our reaction times. So we can see that related words are processed faster than unrelated words, which was the original prediction. And within our results, we noticed that abstract words took more time than concrete words. So you can see that this is median milliseconds, so fewer milliseconds, more milliseconds. And this is both in our target and filler trials. So this suggests that even whenever the words are spelled incorrectly, concrete words are still processed faster than abstract words. So now let's look at the semantic relatedness, which was what the original study was investigating. So for the target pairs, meaning that both words were spelled correctly, participants were able to make a decision on related words faster than unrelated words, which is what the original study predicted. However, we have something different happening over in the filler trials. So our unrelated trials take less time to process than our related trials. So our related ones are taking longer to process than the unrelated trials. Why is this? So our interpretation of these results is that participants, when there is one word spelled incorrectly, are accessing the correct, so they're reading the first word, the priming word, and then they're reading the target word, which is spelled incorrectly, but they're accessing the correct spelling of the target word in their lexicon or their mental dictionary. So they're making this mental edit and realizing, wait a minute, this is spelled wrong. So then they're going back and they're saying, no, both words are not spelled correctly. So there's this interference of the correctly spelled word, this interference with the stimuli that's presented and the actual correct spelling. So this study was really cool because we found significant effects for semantic relatedness, so semantically related versus unsemantically related, word type, abstract versus concrete, semantic relatedness, trial type, and both semantic priming in the target and filler trials, which is really cool because the original study did not investigate the filler trials, they just looked at the target. So this is a really interesting lens to look through at semantic priming. So overall, whenever we are learning about semantic priming, why is this important? Well, whenever we're reading sentences that could possibly contain two words that are in the same category, they could be processed faster than sentences that have words from all kinds of different categories. So if we're wanting to create the fastest possible reading times, maybe we should alter our sentences to reflect more semantic priming. And learning more about semantic priming is important because overall, you're learning more about cognition within people. So, thank you.